Yeah, so welcome to the second part of the conference. We have two speakers in this session. I don't think they need much introduction. They're very well known in the research community, and they've already spoken up. So the first speaker will be Christian Gollier from Toulouse School of Economics, not the Paris School of Economics. And he's the managing director of TSE, and in 2007, he founded it with Jean Tirole, the Nobel laureate, so very prestigious establishment. He's the co-author of the fourth and the fifth reports of the IPCC, and his presentation is up on the screen. So without further ado, Christian, go ahead.
Okay, thank you very much. Thank you. So today I would like to talk about carbon pricing. In fact, not really carbon pricing. I would like to talk about carbon valuing. That is, if we want to do cost-benefit analysis to determine which action should be prioritized in the energy transition. So there are clear costs, and Frank mentioned those costs for some sectors. What are the benefits we put on the other side of the balance? So that's the issue. The difficulty. So the value of reducing emission by 1 ton is the present value of the flow of climate damages that are escaped by the fact that you do not emit the CO2. The problem is you need to determine what discount rate to be used when you do this present valuation tool, when you use this tool. And one of the issues is maybe economists are using a too large discount rate when they do that. I would like to go back to an older question. So last summer, in fact, over the last few years, in particular, and over the last few months, I tried to interact with, décroissantistes, degrowth people or activists from, different NGO. Trying to contribute to our society reducing CO2 emissions. Well, there is a clear, we economists are not very good in conveying the main messages we have in mind when we think about that. And basically, climate activists hate economists. That's one of the conclusions I get from this interaction. They hate us for different reasons. They hate us because first, they hate the message, carbon pricing. And we also hate their proposals to fight climate change by not asking anything to consumer, but putting everything on suppliers of fossil energy. And we know that makes no sense because it's that self-imposing energy crisis of the size, maybe much larger than the size we have seen last year in Europe with the elimination of the supply of oil and gas from Russia. So I will not talk about that. I will talk more about the fact that those activists hate us because they believe economics is everything about short-termism, and we economists do not take care of the long run. And we know the issue behind this problem of being short-termist is what discount rate we use. So we are back to this question of carbon pricing. What would be the level of the carbon value, which depends upon what discount rate we use. And so that's the issue I would like to consider here. Those who know my research know that I've been working on that for the last 15 years. In particular, my interest in the field comes from my background. I'm a decision theorist under uncertainty, and so I'm interested in determining how value are affected by uncertainty surrounding the benefits of the action you consider. Yeah, and typically economists have not, public economists, and in particular environmental economists, have not been very good until recently. And here I took the control of Frank. We have not been very good in including the dimension of precaution and risk aversion in the way we think about how much effort we should perform today in the face of climate change. about the importance of the choice of the discount rate to determine what is the intensity of the effort we should perform today in order to face our responsibility toward future generation. Here is a simple picture, and it's not a picture, just a few numbers that relate the social cost of carbon estimated in the US in relation to the discount rate that have been used by the corresponding commission that make that estimation. And so, for example, you have on the Obama administration, they use a 3% discount rate, they obtain a social cost of carbon of $52 per ton of CO2. There is, and let me forget about Trump. I'm fed up with talking about this guy. Let me just compare the other side of the picture here. In last year, the EPA Scientific Council, or at least member of the EPA, wrote a report where they use a 2% discount rate, and also they changed the climate damage function and other things, and they get to social cost of carbon of $190 per ton of CO2. That gives you the feeling of the importance of the discount rate in the determination of the social cost of carbon. Not a surprise, because most of the action reducing emission by 1 ton today has very long-term impact. This carbon will be there in the atmosphere for decades and centuries, and therefore most of the benefits of not emitting this CO2 has long-term impact. Okay, when we think about how to determine how much we should do to reduce emission, we need to determine what's the social objective, what do we want to perform. And I'm a strong supporter of using the standard utilitarian approach to do that. For 2 reasons, because I strongly feel that the concept of the philosophical concept of the veil of ignorance make a lot of sense when we need to determine the degree of liabilities or responsibility without knowing who you are and to which generation you will belong. I believe that the veil of ignorance make a lot of sense. And on top of that, although I recognize that positively the axioms have been violated in practice, philosophically and morally, I think that the independence axiom that support the expected utility model has a strong normative appeal. And for that reason, when you combine these 2 assumptions, the veil of ignorance and the independence axiom, you get to recognition that in order to determine what is socially desirable under the veil of ignorance is to maximize the discounted value of the flow of expected utility of the different generation who will live on this planet. And so that's what I will do. So I will explore the consequence of this philosophical foundation on what should be the discount rate and what should be at the end, what should be the social cost of carbon we should use when we do cost-benefit analysis of whether I should take my bike this morning to come here in Paris. Obviously, I didn't do that today. Or whether I should invest in nuclear energy rather than natural gas to produce electricity. Okay, so moreover, so you see this social welfare function. Delta is the rate of pure preference for the present. For moral reason, I also impose delta equals 0. I don't think it's morally acceptable to penalize you because you are younger than me. So delta equals 0, and the utility function capital U is increasing concave. The concavity of U represents at the same time risk aversion and the aversion to inequality. Under the veil of ignorance, inequality is risk, and therefore this utility function combine these different features of social preferences. And I use a utility function that has constant relative risk aversion with the gamma representing that degree of relative risk aversion or degree of relative inequality aversion, I should say. Okay, so that's the technical part of the, that's the difficult slide here. So now I have this social objective, and now I think about an action. And this action has an immediate cost and some future benefits. And to simplify everything, I assume here that the benefits is in one single specific day t. Today is t equals 0. T, so t is the maturity or the time horizon to get the benefit. So there is a single benefit bt that materialize in 10 years from now. What's the value of this bt? How society should value the fact that that action that you consider today will generate this maybe uncertain BT, because BT may be uncertain and correlated to future prosperity of the economy. How do you value that? Well, we value that as the maximum amount of money or the maximum reduction in consumption you are ready to sacrifice today in order to get this increase in consumption in the future. So that's the propensity, the willingness to pay. And this willingness to pay, PV, is defined by the fact that if you accept to pay that, if you accept to reduce consumption today by PV, in exchange for getting BT in 10 years from now, you will get the same level of social welfare, intergenerational social welfare, as if you do nothing. If you do nothing, you get the right-hand side of this equality. If you pay PV today and get BT in 10 years from now, you get the right-hand side. And because of the discounted expected utility model is additive, you don't need to take care of what happened in the other dates where no change materialize. And so, if you make the assumption that you do marginal change, so you are along the optimal path, or you are along the equilibrium path. Here I'm thinking about optimality. At the optimum of the efforts you are going to perform, you will get, you can approximate the utility of C0 minus PV as U of C0 minus PV times U prime of C0, and same thing for U of CT plus BT. And that will generate this equation where you express the value of this BT as a discounted value of the expected future benefit, okay, where the ROTI, the social discount rate associated to horizon T and risk profile of the benefit BT, ROTI is defined by this equation, okay? And if in addition, I assume that there is a constant elasticity. So in this, I should have started with this. CT is uncertain. From date equals 0, you don't know what will be GDP per capita in 200 years from now. And probably you either don't know what's the intensity of the benefit your action today will generate for in 200 years from now. So CT is uncertain, BT is uncertain, and also BT may be correlated to CT. And most often your action is the benefits of your actions depends upon the level of prosperity that will be obtained in the future. So let me assume that there is a constant income elasticity of the net benefits of your project, so that and that income elasticity is denoted beta. So this is the assumption I make for the statistical relationship between CT and BT. So beta is the income elasticity of the project. If beta is positive, the project will increase the macroeconomic risk. Because it's positively correlated with consumption. When beta is negative, you have some kind of instance contract. The benefits of your project is larger when CT is small. Okay, and that information will be important in determining the discount rate to be used. So once you plug this assumption into this equation, you get this equation. Okay, you get that the socially desirable level of the discount rate is equal to delta, that's 0 in my moral approach, minus this. Okay, and so if you give me the distribution of CT, if you give me the gamma, if you give me the beta, I would be able to estimate this expectation, I would be able to estimate this expectation, and I will tell you what's the discount rate to be used. Okay, so you need, of course, you need to describe your beliefs about the future when we think about your responsibility toward that future. And that's a critical ingredient. I will come back to that later. So the simplest case is when CT is certain. And let me assume, for the time being, as it has been the case most often in the environmental literature over the last 100 years, let me assume that there is the constant growth rate of consumption. So G here, CT is equal to C0 times the exponential of G times T. G is the growth rate of consumption. And let me assume G is a constant. I know I will grow at 2% per year forever. Let me make this assumption. For the time being, it's crazy, but that's what economists have been doing for a long time now. If you plug this assumption into this equation, well, that's trivial. You immediately get the Ramsey rule. That the discount rate, ρT, to be used for any project will be a constant, delta plus gamma times G. And so the larger the gamma, remember, is the degree of inequality aversion. The larger the G, remember, G is the growth rate of consumption, the larger the growth rate of the social discount rate to be used. So for example, if you assume gamma equal 2, as is usually the case in our discipline, and if you assume the growth rate is 2% per year, you should use 4% as a discount rate for all projects you face, and that will allow you to determine whether the net present value of the project is positive or not. Let me spend some time, because we are here at the heart of the debate with the activists who believe that economists are short-termist. Why do we discount the future? Why do we think 1 kilogram of rice in 100 years from now has a smaller value than 1 kilogram of rice today? Why in economics we so strongly believe that? Well, we believe that because of the Ramsey rule. What's the Ramsey rule? The Ramsey rule, in fact, basically tells us that, of course, in a growing economy, G is positive, in a growing economy, future generation will be better off than us. They will consume more than us. Okay, one observation. Second observation: we are inequality averse. Okay, and in particular in France, we dislike so much inequalities, and we have Piketty and we have all those guys who tell us, oh, we live in a crazy world. We should reduce inequality. We are inequality averse. So let us combine these two elements. We believe future generation will consume more than us, so they will be the wealthy guy. We are the poor guy. We are inequality averse, and we are not ready to sacrifice the current consumption. We are the poor for the benefits of people who will be wealthier than us. So the discount rate in this framework is the minimum internal rate of return of the project that compensates for the fact that doing that project increases intergenerational inequality. That's bad aspects of the project. And that need to be compensated. This adverse effect of increasing inequality on the social welfare function need to be compensated by a large enough rate of return for the project to imply that this project has a positive impact of intergenerational welfare. So that's the idea. Let me, that's technical. I agree the last 3 slides were quite technical, and my activists do not know anything about economics and they are not very good in math. So let me re-explain the same thing without any equation. Let me provide a model-free explanation of why in economics we discount the future at a positive rate. so I take here a model, a reverse version of a model that has been, an experimental model that has been provided by Okun in the 70s that was aimed to estimate the degree of inequality aversion here. So here it's a leaky bucket experiment that I reverse. And I will not spend time in explaining the terminology here. The idea is simple. So suppose that, forget about time, forget about investment. Suppose that X, you have two people, X and Y, and suppose that X consumes twice as much as Y. So X is wealthier than Y. And in fact, it's twice as wealthy. They consume twice as much as Y. The question is, how much are you ready to sacrifice from the poor Y, to give one to the wealthy guy, X? What's the maximum amount of rice you are ready to sacrifice from the poor Mr. Y to give 1 kilogram of rice to the wealthy guy, X? You don't like this experiment because we would like to transfer going in the opposite direction. Okay, you will understand why I force you to think in that way in a minute. Okay, why do we do that? So how much are you ready to give up from the poor Y to give 1 kilogram of rice to the wealthy guy who consumes twice as much rice as the poor? Well, let me assume I have no time to test the number with you. Let me assume you are ready to give up as much as 250 grams of rice from the poor to give 1 kilogram of rice to the wealthy. Let me assume we agree on that. There may be difference in the, let's suppose that there is a consensus on that. Okay, so the value of 1 kilogram of rice to the wealthy is also has the same value as giving 250 grams of rice to the poor. Okay, so suppose we agree on that. Keep that in mind for a minute. Now, let me put you back into intertemporal context where I assume that consumption double in my economy. I assume that consumption double every 35 years. So GDP per capita is 100 now, it will be 200 in 35 years from now. So no uncertainty, growing at 100% every 35 years. And now I raise the same question. How much are you ready to sacrifice from today to give 1 kilogram of rice in 35 years? An investment that generates one single payoff of 1 kilogram of rice in 35 years from now. How much are you ready to sacrifice today to generate that outcome in 35 years to now? So you see, this is exactly the same question. The question is, you are someone, Mr. X, who will live in 35 years from now, who consume twice as what we consume today. And the question is, how much are we? How do we value today the fact that we will give 1 kilo of rice to a person who will consume twice as much as we do? Well, that's 0.25, and it's 250 grams of rice. So the present value of 1 in 35 years from now is 0.25. Okay, so you see the link with discounting. Under this assumption, so if we agree on the consensus, you can check this is compatible with the gamma equal 2. This assumption is compatible with G is equal to 2%. So you get that the present value of 1 in 35 years being 0.25 is compatible with the discount rate of 4%. And this 4% is gamma times G. Okay, so you recover the Ramsey rule. So just to tell you that, we discount in economics because we believe in a growing economy and we are inequality averse. Okay. Application. Let me go back to this famous debate of the middle 2000s, where we met We discussed several of us on this topic. So this Stern report. In the Stern report, we are after the Stern report, we have this debate between Nordos and Stern. Nordos and Stern basically disagree on everything. They disagree for the application of the Ramsey rule. Nordos use delta equal 1.5%, gamma equal 1.45, and G equal 2.15%. You get a very large discount rate and therefore a very, very low social cost of carbon, whereas Stern proposes a much smaller delta, a much smaller gamma, a much smaller G, therefore get a much smaller discount rate and therefore a much larger social cost of carbon. So who is right? Well, let me go back to the jury here, and I have here a short list of famous experts that took a position on what gamma should be, what the discount rate should be. And you see, I will not go into the detail. Gamma equal 2 looks like some consensus in our profession. And so if gamma equal 2, if you agree that delta should be equal to 0% for moral reason, then you get that the discount rate should be 2 times the growth rate of consumption. And that generates the 4% if you assume G equal 2%. You know what? They are both wrong. And how can we as economists forget about the deep uncertainty we face about G? I mean, making the assumption that we will grow at 2% per year forever, of course, that eliminates any responsibility for our generation, which is so poor in the face of the future risk we impose to the future generation. They will be so much wealthier than us. Why should we take care of them? Okay, and so that's implied the Nordos position of a very low discount, a very low social cost of carbon. So the reality is, of course, we don't know. We don't know whether we will be wealthier or whether they will be wealthier in the future generation or whether they will be poorer than us. And there is a strong debate about that for a long time now. You know, secular stagnation, catastrophic events and end of the end of history and all those things. So we don't know what G will be. So maybe Nordos will be correct. Maybe Stern will be correct in terms of G. The point is we should recognize today that we don't know what will be the prosperity that will be that future generation will enjoy. And we need to take into account of this deep uncertainty when we think about how much effort we should do for those people. Okay, so we have a model. What is surprising is that we have a model for a long time now, more than 30 years, for 40 years. That's the consumption-based capital asset pricing model. I know there are a lot of presents associated to the models in order for this model to explain the real world. But again, on normative ground, I'm not here trying to understand how in the real world we price the carbon. I would like, the question is what should be the price of carbon? Huh? So it's a normative problem. And if we apply this same normative approach with the social welfare function that I introduced earlier, where now I recognize that CT is a random variable and in fact it's a stochastic process, and if I assume a geometric Brownian motion for this discrete version of that, 5 minutes. Okay. I believe that I would have 12 minutes, but okay. We start 10 minutes before. Okay, I will not negotiate that. Okay, thank you. So yes, so the extension of the Ramsey rule to the recognition that CT is a geometric Brownian motion will imply that the discount rate we should use is proportional to the beta. Remember, the beta is the income elasticity. And so we have to, we have a discount system. Okay, we don't have a single number for the discount rate. We have a discount system that is defined by the risk-free rate and the risk premium, and beta is a number that is specific to the project itself. So we should use different discount rate for different projects. And you know what? We are the only country in the world, and I thank him, Emil, for bringing us there. We are the only country in the world that is that recognize that the future is uncertain and recognize that the net benefits of projects are uncertain too, and that it induces us to adjust the discount rate to this risk profile. And you see that we should use the larger discount rate, for a project with a positive beta, because pi is positive. Sigma is the volatility of the growth rate of consumption, so this number is positive. So when beta is positive, we have a project that increase the macroeconomic risk, that impose more risk for future generation. We should use a larger discount rate. It's a way to penalize those projects compared to other projects where beta is negative, that generate larger benefit, social benefit when GDP per capita is small. So that's provide an edge against the macroeconomic risk. And we should use a discount rate that is smaller than the risk-free rate for those projects that generate the bonus for those projects when we perform the cost-benefit analysis. Okay, and then the question is, what's the beta of reducing emissions of CO2? Do you think that that kind of project, investing in photovoltaic panels or nuclear electricity or electric car or using my bag this morning, what's the beta of this action? Implicitly, the question is, marginal damages, are they positively or negatively correlated to GDP per capita? Okay. Do we think that in reducing, implementing energy transition, do we think that it is also useful to reduce the risk borne by future generation? That would be the case when beta is negative. That would imply that we use a discount rate that is smaller than the risk-free rate, and that would tell us that Stern was correct to use such a small discount rate of 1.4% to determine the level of the social cost of carbon. Okay, so I will not go into the details later in my presentation for the lack of time or for the benefits of your lunch. I will drop. So what I do in my research typically is I give up the assumption of geometric Brownian. Do we really think that we can represent the prosperity of the future generation on this planet by just a trend of growth and some volatility around this growth? If you believe this, tell me what's the trend of growth for the next 3 centuries of the world GDP per capita. No, this is clearly, if we believe in geometric Brownian motion, this is clear that this parameter is itself uncertain. Okay, and moreover, there are catastrophes, there are macro-catastrophes that cannot be represented by a geometric Brownian motion. That should also be included into our representation of the risk we face for the long term. All those things imply that this kind of model underestimate the impact of risk and uncertainties on the way we should value today the benefits for the future. Okay. Yeah, let me, how much time do you have, Mr. President? Okay, good. Natalie is not happy with that, but I get this. You are the boss. You are the boss. Okay. Yeah. Okay. Yeah, no time to talk about that. I have a paper with Aude Pommeret and Frédéric Cherbonnier where we try to, because one of the problems is, it seems that this discounting system where you have a risk-free rate and a risk premium, and you adjust the risk-free rate by imposing a positive or negative risk premium depending upon the beta of your project. This seems to be too complex. Even in France, where Emile established this risk-adjusting system, I didn't see any project that have been formally using this approach. Even when the state planned to spend 25 billion euros, that was not made, okay? So that's probably because estimating the income elasticity of a net benefits seems to be too difficult, in spite of the fact that you just have to do an OLS estimation. You just have to do an OLS estimation where you regress the log of the net benefits on the log of GDP per capita. That should not be too complex, but it seems that it's too complex anyway. So we are proposing an alternative to that discounting system. I will not spend time on that. Let me go to the discount rate for climate change. So let me go back to this question. Do you think that when I reduce by 2 tons of CO2 in 2023, my own emission of CO2 by replacing my Twingo car, I leave it in my garage and I go every day to my job by bike, I save 2 tons of CO2 by doing that. Do you think that this action not only reduces, of course, in expectation the damages that I impose to the future generation, but do you also think that we should take into account of the insurance benefits, the fact that this action also reduces the risk borne by future generations? Or do you think the opposite, that that would increase risk borne by future generation? Well, there are 2 competing stories about that. The first story is our models, the models we use in economics, in this integrated assessment model, on which I'm not an expert at all, but those models traditionally make the assumption that damages are proportional to consumption. Okay? If there are more apartments along the beach, there will be more damage when the ocean will submerge those apartments. Okay, so more prosperity will imply more losses. Positive beta. In fact, beta equal 1 in that case, if you believe that the damage are proportional to GDP per capita. So beta positive, beta equal 1 in this case, wow, you will have a large discount rate and a small social cost of carbon. So integrated assessment models have that problem. Huh? They are good in estimating the expected damage, but in fact, investing in transition will increase the risk borne by future generations in that case. But there is another story. There is another story that generates a negative beta, and that will generate the fact that using my bike also provide also an insurance for future generation. And the story is the following. I have different papers making different stories. So I need to a larger climate sensitivity raise. Yes. So when you introduce in traditional integrated assessment model uncertainties about, for example, climate sensitivity. Okay, we read the last report of the IPCC. You will see that there is still a very huge uncertainty on what's the climate sensitivity. When you double the concentration of CO2, by how much you increase the average temperature on this planet? It's somewhere, I don't remember the number, but we believe it's around 2.5. But the 75% probability interval of confidence is something like 1.5 and 4, something like that. So that's extremely large. So in that case, if it happens that you learn in the future that the climate sensitivity will be larger than expected, it will be 4 degrees rather than the 2.5, which was the point estimation, well, Of course, bad news. Bad news, it will reduce consumption because we will face all those damages generated by this unexpectedly large increase in temperature, whereas at the same time, the marginal benefits of fighting climate change today will be large. Okay, because we underestimated the impact of the marginal damages, so the benefit will be larger at the time where aggregate consumption will be small. So you see here appearing this negative correlation between BT and CT, between the net benefits of the energy transition and future prosperity. And therefore, beta is negative. I'm done. The beta is negative, and you should use, therefore, a discount rate smaller than the risk-free rate to evaluate the social cost of carbon, and you will get a social cost of carbon that is even larger than the one that has been estimated by Stern. So what's the true story? In which role are we? Well, I'm sorry to tell you, the jury is still out. And in fact, we are not many. We are not many in the profession in trying to solve this issue. So here is my paper with Simon Dietz and Louis Kessler, where we show that I will not have no time to go into it. You have a positive correlation between BT and CT. I'm sorry, I changed the notation. I get estimation of beta of 0.7. But recently, I worked with some colleagues from Arizona. And there I see a very negative beta, and therefore, if this is true, if this model is more correct than the previous one, I should use a negative discount rate for estimating the social cost of carbon. I'm done. Thank you very much.
Thank you. Thank you very much. Natalie, do we have time for a couple of questions, quick ones? One question. Okay. Yes. Yes.
Whether this is a geometric Brownian motion or a Levy process or whatever you want, you will have exactly the same problem. You will have to specify the parameters, and probably it is extremely difficult to say something about the parameters. So perhaps, I don't know, an alternative way is just to specify scenarios where you think you cannot assign probability to scenario. I just don't know. But my feeling is that if you refuse to work, let's say, with the Brownian motion, I mean, I understand that you refuse to work with a stochastic process in which you make some assumption about the parameters.
No, I did agree. In my Journal of Monetary Economics paper, 2017 or 16, I don't remember, I put a probability distribution on mu. Okay. So today, and I will learn about mu in the future by observing the annual growth rate. So I'm still in a probabilistic world. Maybe you want to push me, and I see Loic on your right, you want to push me to recognize that we should be ambiguity averse. I fully disagree on that, okay?
Just one thing. So I agree with that, but so I mean, once again, I don't want to be the lawyer or, let's say, particular stochastic process, but then when you work with a geometric Brownian motion, you could simply assume that, let's say, mu and sigma are stochastic, and then, for instance, you can assume some distribution, and you learn over mu and sigma conditionally about the past information.
In that paper that I just mentioned, I look at different stochastic process with parametric uncertainty, and yeah. At the end of the day, I just want to make the point that if we want to think about what's our responsibility toward future generation, we cannot escape the discussion about what our belief about the future. Okay, the two things are linked. If we are unable to agree on the kind of maybe hopefully, from my point of view, a stochastic representation of the possible future, there is no way to discuss about what's our responsibility, what's the responsibility of the current generation toward those future generations. So we need to have a debate like that. It should be probabilistic for the maturity for the time horizon we have in mind. And it's a difficult issue. But there has been papers. I think Loic has also a paper with many co-authors on this survey of economists trying to elicit growth rate for the next century. But they also, yeah, okay, I want to stop here.